Again from M1, Mechanics M1, January 22, question number 7. A particle P of mass 4m lies on the surface of a fixed rough inclined plane. The plane is inclined to the horizontal at an angle alpha, where tan of alpha is 3/4. The particle P is attached to one end of the light inextensible spring. The string passes over a small smooth pulley that is fixed at the top of the plane. The other end of the string is attached to a particle q of mass m, which lies on a smooth horizontal plane. So the horizontal plane is smooth. There's no friction. And the inclined plane is rough. The string lies along the horizontal plane and in vertical plane. The string lies along the horizontal plane and in the vertical plane that contains the pulley and a line of greater slope of the inclined plane. The system is released from rest with the string taut, as shown in figure 4, and P moves down the plane, obviously. The coefficient of friction between P and the plane is 1/4. For the motion before Q reaches the pulley, write down an equation of motion for Q, 1 mark. Find in terms of M and G the tension in the string, 7 marks. Find the magnitude of the force exerted on the pulley by the string, 4 marks. State where in your working you have used the information that the string is light. So here, the first part, equation or write the equation of motion for Q. So the pulley is smooth, the string is light and extensible. So the string is light and inextensible. So the tension throughout the string would be the same, T newtons here and T newtons here. Okay, and relative to the T newtons here. So relative to Q, I should mark the direction for the tension leftwards, and let us mark the direction for the other particle. First part is write down the equation of motion for Q. So the weight is there, so it is moving towards left. So obviously there is acceleration. The acceleration is let A meters per second square, and as they are connected by the light inextensible string, so for this particle it is again A meters. So this is the basic working for such figures. First part is equation of motion. So on as this is smooth, this is smooth. So there is no friction. So the force acting in the, so if P is moving down the slope, so Q is moving towards left, and the force acting in the direction of motion is only force T newtons, no other force. There is no friction. M is the mass. So and A is the acceleration. So for A part, the answer is simple for 1 mark. Moving here by Newton's second law of motion. By Newton's second law. Newton's second law, which is F equals to ma leftwards. So T is equals to m into A. This is first part answer. The second is find in terms of M and G the tension of the string. Okay, tension we've taken as let the tension. So tension is T, and the acceleration we have taken as A. So the tension is T newtons, and acceleration I'm using here as A meters per second square. For the second part, a lot of work is involved here. The mass of Q is given. For the P, the weight is 4 mg newtons, and the normal reaction is here, normal contact force, because it is rough. So R newtons is the normal reaction. So normal reaction here I'm taking as R newtons. you can resolve into the components this force of 4 mg. This angle is alpha, this is alpha, basic working, and because 90 degree and this would be 90 minus alpha, and 90 minus alpha further subtracted from 90 is, so this angle is similar to that, basic knowledge. Next is 4 mg sine of alpha here, and 4 mg cos of alpha is here. So sine of alpha, we need the value of sine of alpha and cos of alpha. Either you can find the value of alpha, or you can do basic working, like if there is a triangle, sine we know is tan we know is opposite over adjacent. So this is 3 over 4. By Pythagoras theorem, I can find this as 5. So this is the simple working for finding what is sine of alpha. The sine of alpha from this triangle, if by Pythagoras theorem, if you have 5 the hypotenuse, then sine of alpha is opposite over hypotenuse, and cos of alpha is 405. So you can use these values, sine of alpha and cos of alpha, here in 4 mg cos of alpha and 4 mg sine of alpha. So for we have in part A the equation of motion for particle Q. You can also write the equation of motion for particle P, but for this we need to find the friction because it is rough. So where is the friction? Friction is acting here in this direction. This is friction, opposite to the direction of motion as it is coming down. So, and for the friction, we have the formula mu r. Mu value is given. Mu is 1 over 4. So F equals to mu r. So we need r. So r first calculate for P part. We start the working like this. R is equals to 4 mg cos of alpha. 4 mg cos of alpha. R is 4 mg cos of alpha, and cos of alpha is 4 over 5 here. So 4 over 5. So R is equals to 4 mg 4 over 5. So R value is 16 over 5 mg. This I can use here to find the friction. So the friction force is F is equals to mu R. F is F and mu is given. R is 16 over 5 mg. In this way, the friction is equals to, so the friction force is equal to 16 4 times. This is 4 over 5 mg newtons is the friction. 4 over 5 mg is the friction. So as this particle is coming down, so this I'm talking for the particle which is on the inclined plane for P. For P which is of 4 m. This is working for that particle. So as it is moving down the slope, so again by Newton's second law, F equals to ma down the slope. So force acting in the direction of motion is here. This is the force acting in the direction of motion. 4 mg sine of alpha minus 2 opposing forces T and the friction. 4 mg sine of alpha down the slope. 4 mg sine of alpha minus 4 over 5 mg the friction minus T is equals to 4 ma. F equals to ma. 4m is the mass and a is the acceleration, which is common for the both particles. So here I can use the value of instead of angle straight away I can use the value of as a whole sine of alpha is 3 upon 5. So if it is 3 upon 5, I can write 3 over 5 here. In this way, I can get the answers in the exact form. Minus T is equals to 4 ma. So simplifying 12 mg over 5 minus 4 over 5 mg minus t is equals to 4 ma. So question was to find in terms of m and g the tension in the string tension. So keep in mind that already we have an equation t equals to ma. We can use this and we'll be using this equation in the second part. T is equals to ma or ma is t. So here what I can do, I can simplify 12 over 5, these two are the like terms, 8 over 5 mg minus t is equals to 4 into ma. So what I can do, so what I can do after this. So we have ma, ma is equals to t. So either you can use t equals to ma or ma can be replaced by t. So using 1, I can write 8 over 5 mg minus t is equals to 4 and t. So 8 over 5 mg is equals to 5t. And further 5t is equals to 8 over 5 mg, or t is equals to 8 over 25 mg. This is the value of the tension in the string. Tension in the string is here, 8 over 5, 25 mg. This was part number 2, basic simple working. Find the magnitude of the force exerted on the pulley by the string. Force on the pulley. The force on the pulley is basically this force. Pulley is here. There are two forces, tension and tension on this side. So relative to this pulley, this is the pulley. So the rule for the tension is that it is always away from the object under consideration. So I should mark tension here. This, so we have, this is the force exerted by the string on the pulley. This is the force. This is the force exerted by string on the pulley. This is the force on the pulley. So I can mark this as force X. So X newtons is question mark. This is X. So this force is X, the force on the pulley. So next we'll find X. So there are many different methods for solving this, for finding this. Yes. So for this part, what I can do, my entire focus should be here. My entire focus should be here. So T, T, and X. So let us draw this. I'm trying to draw it here. Yes, I can easily draw. So one force is here, which is T newtons. Pulley is here, pulley. And the other force is here, which is T. And this is the force which I'm trying to find. T we already have. This is T newtons. The T value is there. And this angle is alpha. This angle is alpha. So one method can be, like, as this is the question mark, so what you can do, you can find the resultant of this T and this T. So by head to tail rule, you can connect this factor, the other, you can draw this force here. Here, this is T, this is T. So these are the two forces, head to tail rule you can see here. This T plus this T, and question mark is here. This angle is alpha. So you can find this value of X. So by this is part C. Then there is a shortcut to this again. So next I'll explain the shortcut for solving such situations. By cosine rule, by cosine rule, this is basically isosceles triangle. You can apply the cosine rule. X square is equals to t square plus t square minus t square plus t square minus 2 into t, which is t square, into cos of angle opposite to x, which is alpha. So x is equals to 2t square minus 2t square cos of alpha under the root. X is equals to 2t square minus 2t square. The cos of alpha value is 4 over 5. This is 4 over 5. I can write 4 over 5 with square root. Then x is equals to 2t square minus 8t square over 5 with a square root. So x is equals to 10 minus 8, 2. So this is 2 t square over 5. And then using the value of t, which we have calculated, 8 over 25 mg. 8 over 25 mg. So 8 over 25 mg. T is 8 over 25 mg. I can use it here. So 2 over 5 t square, I can write 64 over 625 m square g square. X is equals to, you can simplify, you can write the answer in decimals. This is basically 64 square root you can find. And yes, answer can be in decimals, or answer can be in the exact form. So here I can write this is 864. I can write 2 over 5 into 625. 2 over 5 into 625. 3125 denominator. 3125 denominator square root. The rest I can write 8 mg, and if you use calculator, or you can find this answer as finally equals to 8 mg is there, root 10 over 125 into 8 mg, or x is equals to 8 mg root 10 over 125. So if you're not comfortable with this type of working, what you can do after reaching here, you can use calculator to get the answer. So 2 multiplied by 64 divided by 5 and again by 625, and the square root of this is 2 multiplied by 9.8 is 1.9 1.98 m or 2 m, 2.0 m. So still okay. If you leave your answer here instead of writing the answer in the exact form, because this is not the requirement in the question to write the answer in the exact form, 2.0 m. Or you can use basic mathematical concepts to get this type of answer there. So 8 mg root 10 over 125 or just 2 m or 1.9 m is the answer. This is one approach. The other approach is very simple. Or part C. Simply for this, you'll have to keep in mind a formula. This force was T newtons. This force was T newtons. Here was the question mark, X newtons. For this, we need to find the angle between the two forces. These two are the forces of the same magnitude. So tan of alpha is 3 upon 4. So you can find this angle. How to find that angle? Simple technique you can apply. The lines are parallel. So 3 over 4 inverse tan is 36 point. This is 36.87. 36.87. So 180 minus 36.87. So this angle between is 143.13. X can be obtained directly. There's a formula 2t cos of, so say this angle is theta between the forces. 2t cos theta over 2. So x is equal to 2. We need to know the angle between the two forces T and T. So 8 mg over 25, the value of T, cos of theta over 2 means 143.13 divided by 2, the half of the angle, which is 71.565. You find the cos of this angle, multiply by 16, divide by 25, and again multiply by 9.8. So the answer is coming as 1.98 m. Just in 2-3 lines you can get this value, or a better answer can be 2.0 m, or even if you write just 2m, all these answers are correct, because answer should be can be the three significant figure, 2 significant figure. So it's the structures are on the first page. When our numerical value of g is required, take 9.8 and give your answer to either two significant figures or three significant figures. So all these answers are acceptable for this question. So for the last part, I can give you further detail, and that is that whenever there are two forces of same magnitude, say P newtons and P newtons, and if these are acting at a point, so the formula for finding the resultant is, if this angle is say theta, so I can write over here. So this is the formula for the resultant of two forces, resultant of two forces of same magnitude. If P and P Newton are the two forces and the resultant is here, so this resultant is actually 2P cos of theta over 2. 2P cos of half of the angle between the two forces which are of same magnitude. 2P cos theta over 2 is the formula. 2P cos theta over 2 is the formula for the resultant. So as this was 10 newtons, this was 10 newtons, same magnitude, angle you can find between them. So the resultant was question mark. So 2T cos theta over 2 is the answer. Well, for the last part of this question, the last question part is state whether in your work, where in your working, state where in your working you have used the information that the string is light. So because of the light string, the tension is the same throughout a section of the string. So this string, which is this part of the string, the tension is the same throughout this section, and also the tension is same throughout the other section. So here you'll have to state where you have used this information. So for part D, the working is the comment is uh, tension will be the same throughout a section of